good evening and a warm welcome to today's hands-on bootcamp where you will get to build a fully working application in just under 30 minutes. I am 𝗖𝗲𝗀𝗃𝗀𝗃𝗀 and I'm the Director for Community and Partnerships with OpenWeaver. OpenWeaver is a SaaS technology company supporting over 1 million developers worldwide build their ideas faster by reusing open source software. Our vision is to reinvent digital realization. Very simply put, we'd like to improve the way applications are built. We do this by investing in a unique combination of both public domain knowledge and artificial intelligence. So coming to today's bootcamp, this is an integral part of our OpenWeaver community initiatives. The OpenWeaver community is a body of like-minded technology enthusiasts and open source contributors who have come together with the vision of contributing to the world of open source and sharing how complex use cases can be developed by reusing open source. Over the last few weeks, we have run several such open source development bootcamps on a variety of topics, such as building your own AR-powered e-commerce site, building your own ChatGPT, building a breast cancer prediction engine, building an object detection engine, basics of Python programming, and many more to come. Through these bootcamps, you will realize that technology does not have to be complex and definitely does not have to be developed in silos. You will see how you can take a solution that is pre-built, in fact pre-built by many people in the world, and then you can build on top of it and share it back such that your solution can now be accessed by many other people in the world who can then further build on top of your ideas, thereby accelerating this virtuous cycle of innovation and also helping you scale your ideas and bring it to life much faster. So with that brief introduction, I will now welcome our mentor for today's session, 𝗤𝗲𝗀𝗃𝗀𝗃𝗀, who is a senior developer advocate with OpenWeaver.
Hello everyone, welcome to today's session on building your own movie recommendation system, where we will discuss about the basics of NumPy and Pandas and how you can use these to build a very simple recommendation system. So let's get into the agenda for the day. First of all, we will get an overview of the Python libraries that are used for data science. So Python is the prime one, and NumPy as well, which we'll talk about primarily for developing the use case. But we'll also have a brief on the various other libraries that you can use as an individual who's beginning to set up their journey in data science. And then we will also do interesting code snippet exercises with Pandas. So these snippet exercises will help you build up confidence in working around data sets, how you can merge data sets, how you can sort data sets, and in fact perform many other operations on different data sets. So we'll do those as well, and then gradually we will have the entire solution in front of you, which we will discuss in detail. So let's get ahead and first of all check out the solution that we will use today. So this is the solution that you would be setting up onto your systems, and I will guide you as to how you can set this solution onto your system. I have a database of ratings. So I'll tell you, I have 4 data sets, okay? And 4 data sets I have merged in a way that I'm able to get the title, movie ID, the genre of a particular title. Let's say if you have heard of this movie called Toy Story, so it also has adventure but animation, children's story, it's a comedy and fantasy movie. So what all genres it can fall into, and based on a particular movie, how the user has rated with a certain, how a particular user has rated that movie and at what timestamp, we are able to get, after doing some operations on our data set, to this point. Okay, and then once we have the data set which we want to use for building a recommender. So all of you know that nowadays we watch a lot of Netflix, Amazon Prime, and web series. As to, all these OTT platforms help you uh, help you get to suggestions as to what you should watch on a particular day, what's trending and what else. So depending on whatever is your likability as well, it will also start giving you recommendations based on, let's say YouTube gives you recommendation based on the search and a video that you watch. So similarly, we will help you with the entire logic. So just wait and hold on for me to explain you the logic as to how we have developed this code. For now, I have chosen, let's say, Toy Story as one of the movie. And based on Toy Story that I've already watched, I want to get more recommendations. Okay. I have got recommendation for 101 Dalmatians, American Tail, Blue Velvet, etc. So many of these movies. This is one way where I have used one technique to get the recommendations, and here using another technique by similarity on the genre feature. So one is based on similarity between the ratings by which user have rated the movie, okay, which is collaborative filtering. If one user has rated a movie highly, then another user has also rated that movie highly, then we've used that technique to find out similar movies. Another technique I have used to get to other similar movies to Toy Story. Okay, so we see here the suggestion is a bit different, and here the suggestion is like, and American Tail is common in both, but the sequence is a little different. So we'll talk about these techniques. We'll actually be working on this solution today with you. So stay tuned. I will now help you set this kit onto your systems. Okay. So for that, you will have to get onto this community page where you are currently viewing the session. Okay. And then you will see under the resources section, you have an option to click on this kandi one click kit button. Okay. So what is this kandi one click kit button? Here is where your solution source is available. Okay. Alongside with the solution source, all the required dependencies, requirement for Python, Jupyter Notebook, Pandas already being set up as one of the dependency. Only then I can import it in my code, right? Panda, NumPy, etc. All those will automatically get set up onto your system. How? Just follow alongside with me. So you see that there are some instructions also listed down here. And for now, I will go ahead and say, I want to set up the one-click installer. I downloaded this. I would say show in folder, and then I will just extract all the contents of this zip file. After I have extracted this folder, kit installer 2, I will double click it. I will see that there is a batch file available. So again, I would like to bring it to your notice. Do not directly get to the batch file. Always unzip your zipped file, okay? Always unzip your kit installer file, then get into this folder and you will have the batch file. Double click it, say more info, run anyway. So this will start setting the kit onto your systems. And then when it is setting, it will check what all is available. If not, then it will start setting up. So I have Python already set up. So it is saying that it is already there. So skipping installation for Python and then proceeding with other required dependencies. So let this setup happen. Let this repository get downloaded. Let the source code be there onto your system. Your Jupyter notebook will automatically open when you would get a prompt to say yes. So minimize your screen for now. We will discuss the concepts for the session as of now, and then we will get back to our solution source. Okay, we will get back to this use case soon. So even before we go ahead, I also want to talk to you about what all is available on this page. So we have information on the learning objectives. What are the key things that you are going to learn from the session? You have the solution source or your kit that we are going to demonstrate. You have opportunity to do very simple coding exercises that I'll discuss through the session, and then through this during this session, and then you have your assessment as well. So the assessment is something that you can take post the boot camp. You also have a chance to earn yourself an open source enthusiast badge. So to be able to earn this badge, you just have to set up the kit like I'm just letting it run. And then when the Jupyter notebook will open, try to tinker a little bit with the code. Once you tinker with the code and share a screenshot, with us by clicking on this reply button, we will give you an open source enthusiast badge. You just have to show some enthusiasm, you know, do some tinkering with the code, and then we will give you this open source enthusiast badge, which is very powerful, that you can showcase on LinkedIn, on different social media. But remember to sign up. You may not be signed into the community platform. Go ahead and sign in to use the reply option. Okay, I see one of you have already started playing with these polling questions. So you can also interact with these questions on the platform during and post the session if you would like to check out your knowledge that you already have on pandas and movie recommendation engine. So with this, let's start our today's session. I hope the kit is already getting set onto your systems. We want to talk about the essential libraries, Python's essential libraries for data science. So we primarily are looking at NumPy, SciPy, Pandas, and scikit-learn. So these are really popular and used in most of the applications which you are developing around machine learning, around data science. Even if you're doing mathematical operations, then you would need this numerical Python, scientific Python, Pandas, scikit-learn, which is a complete framework and has algorithms, libraries, modules for machine learning and deep learning. We also have libraries which are specifically used for visualization purpose, matplotlib, seaborn, etc. So what is the essence of these libraries? What is the importance of these libraries? Why is Python so popular? So the thing is that these libraries have made it so much easier for us as users to just call in a function from a class that is already available in them. Okay. I will show how I will use merge as a function and be able to merge two data sets. How we will sort two data sets using sort function that is already available within the pandas library. So that is why we want to study about these, and that is why our focus is that as we learn a particular library, we also develop certain application using it. So talking about pandas, this helps in structuring. It is basically a tool that will help you put your data in a tabular format. So basically in a series or data frame format is what you can put your data set. And that's how pandas become a really good tool when you want to do data manipulation, when you want to recreate a data set from a data set, reshape it, you want to do merging of your data sets. Like I just showcased you, right? I will have small four data sets, and then based on the column, I will do merging or I will do sorting. So slicing is again uh, extracting a certain part of your data set. So that is slicing. Aggregation, all the aggregation operations that you would want to do on a database, you are able to do with the help of pandas, and you use data sets here. Also, pandas help you in handling missing data. So not all data is the way that you want, right? There is a big boom, and the nowadays data is being generated every now and then. Every day on YouTube there are nearly 47 lakh videos that are uploaded. Can you imagine the massive growth of multimedia data that is being generated each day? That's why you should be able to understand as a technology enthusiast how you can handle that data better. So you want to handle it better using this pandas library. So we want to also talk about this NumPy as well as SciPy. So NumPy is for multi-dimensional arrays and matrices. So whenever I want to say I'm working, doing some analysis with my data, it is essential that I'm able to perform mathematical operations on it, do statistical operations on it. Only then I will be able to extract the required insights from it. So, NumPy has functions which are able to do vectorization of various operations on arrays and matrices. By using that, we are able to improve the performance and the way in which the data is provided to us. So there are many other Python libraries which are built on NumPy, not just NumPy is built. Your SciPy is also built on NumPy. Okay, So it's part of the SkyPy stack. Your But then if you talk about the scientific Python, obviously it has more algorithms or inbuilt modules for linear algebra, metrics. No, sorry, not metrics, but yeah, numerical integration, differentiation, your optimization. So the more complex concepts are being covered in SkyPy module. Then comes in your visualization library. So these are also very important. You are able to plot you are able to plot, say, you are able to differentiate among different features by plotting them on a 2D plot. Okay, so matplotlib does what? We are able to do comparison, that at a certain time, at a certain slot, in a certain year, how has been the progress. Okay, for something, let's say if you see the first graph, 2011, 2013. So it's a 2D plot, and then it is helping you, in different ways. It can help you with line charts, line plots, scatter plots, bar charts, histogram, and so many such visualization variants, with the help of which you are able to compare that what particular product is working. Let's say in your company you have multiple products, and then year by year you want to check what are the products that perform better than the others. So you can do that kind of visualization and much more than what I am just saying with matplotlib. So this is a little more simpler, and there is effort that you need to do when you're working around with advanced visualizations. So for that you have another library which is called 𝗖𝗲𝗀. Just like NumPy and SkyPy, Matplotlib is the basic version, and 𝗖𝗲𝗀 is a little bit more advanced version where you are able to do this data visualization. And this 𝗖𝗲𝗀 is again also based on Matplotlib, but you can do better visualization, advanced level visualization with the help of 𝗖𝗲𝗀, and actually get attractive statistical graphs. Okay, with the help of this library. And then comes into scikit-learn, which has algorithms of machine learning like your SVM, your decision tree, your random forest, like not just the supervised but the unsupervised one already listed down, classification, regression, clustering, even the different parameters for model validation, whether the model that I have developed is correct or not. Everything is already available. So that is what makes this entire spectrum of libraries very interesting to learn about, know, and are also necessary to know when you are building something interesting. And the scikit-learn, it is built on SkyPy, NumPy, and Matplotlib, all three. Now we quickly move to our movie recommendation system, which is our intention, which is our use case for today using Pandas. So here, what I will apply when I will use this, when I'll demonstrate again in detail, we are using collaborative filtering, the technique where one user, and we will take the similarity of one user with the another user. We want to check out how similar are two users, and based on the similarity score, we will suggest the movies of a user A to user B. Okay, let's say A and B have the highest similarity score. So then we know that A also watches comedy movies, and then why not B? Let's suggest some comedy movies to B as well. So how do we do it? We try to calculate, or we try to filter and find out what products a particular individual likes. So let's say, how do I get those suggestions on Amazon for products? People also bought similar products. You must have seen, right? So that is based on, I'm trying to buy an electronic device, and let's see what other electronic device I would like to buy. But let's say Amazon is pretty big. Let's say just your cosmetics. Okay, a certain female buying certain cosmetics and the right kind of cosmetics being suggested, then there is a chance the female would actually buy the other options or the other suggested variants that are available. So that kind of technique is your user based collaborative filtering, where we would recommend items bought or liked by one user to another user, assuming that he might also like those items based on similarity. So this is the technique that we would follow. And for this, we have used nearly some 1 lakh ratings and 3,683 tags across nearly 10,000 movies. So this is a movie lens dataset that we are using, and it is created using 610 users which had rated multiple movies. So every user at least rated 20 movies. Okay. No information regarding the demographics is available. And we have features such as IDE and uh, the rating that they have provided as a user, but there is no other information that is available. Okay. So you have your links.csv, movies.csv, ratings.csv, and tags.csv. These are the four data sets. So I'll show you these data sets. But before that, we will quickly talk about how your pandas data frame can help you arrange data in the two-dimensional structure, rows and columns that we are going to use to work around today into our solution. Okay, so I'll quickly show you reading data using pandas can be done using PD. Okay, PD is an alias for panda, and we have a function called read underscore CSV. So we just want to read a particular data set which is in a CSV comma separated format into this data frame. Okay. DF is a data frame which is a row column format. Let me show you this. So once you have successfully reached this level onto your kit, it's saying 100%. Just say yes, enter. The Jupyter notebook will directly open for you. And as your Jupyter notebook will open, just say restart and run all. All right. So once you have restarted and run all, we want to discuss the solution source, and we want to talk about this movie recommendation system. I want to show you how I have read my first data set, which is links.csv. I've imported these essential NumPy and pandas, and I've set pandas as PD. And within the PD, when I will go here and say tab, okay, let's just stop the kernel. Seems like, yeah, now we have our code running completely. Okay, so what did we do? We basically read your PD, which is your alias for pandas, and then called out one of the functions, read CSV. So there are so many functions that are available. Okay, so there is read underscore CSV, there is read underscore Excel, read underscore feather, whatever. I mean, the number of formats, HTML, JSON, whatever you want. You just press tab, okay? Once you have this dot operator, just press tab and choose the format that you would like you to read your data set in. And this is the folder in which I have kept my data sets in this format. Then I have created a data frame, okay? This is what a data frame is. This is how it is being showcased in a row column format, a table, simple table. Okay, and this is head. This head function lets you showcase the top 5 rows. If I write a layer, it will showcase me the last few rows. So you see we have nearly these many movies rated, and this is having a movie ID, an IMDb ID, and a total movie database ID. Okay, these are simple IDs with which your movie has been uh, particularly pointed, or let's say they are with the different IDs, they are stored in this row. Then you have an option where I have also read my movies.csv. What is the movies.csv dataset? I can also read, let's say, 9 rows. I'll rerun this. And when I rerun this, I would see that for 9, from index 0, all my 8 columns have been read correctly. So Toy Story is there, and then the different genres for it is there. But I have my data set in different formats. One in this format, then one in this format. Oh, this seems like it is repeating the output. Something's gone wrong with the kernel. Let's just refresh all of it. Start and run all. So sometimes that happens with the kernel. You can also check by restarting the kernel, letting it shut down. Yeah, we see now only one table. Okay, this is the perfect outcome. And then we read the third one, which is ratings. So here we have user ID, movie ID, ratings, and timestamp. Here again, the code is getting stuck. Similarly, you have your fourth data set, which is your tags.csv. So your tags.csv, here you will have, let me show you the tags.csv. Here you will have user ID, movie ID, tag, and timestamp. So now what we want to do, we will merge these. Why will I merge these? I will merge these to fetch only the essential features in my dataset. And why? What all I want to do? Based on a person A who likes a certain set of movies, I want to give them, I want to suggest those to a person B who may like any of the movies that A like, because there is similarity between the movies that A and B like. So therefore, we want to suggest the movies of A to B and B to A. So what we did, from our movies data, movies data frame, your movie data frame, this I want to merge, and I want to merge it on movie ID with my ratings dataset. So then with movie ID, title and genre, now I also have user ID, ratings, and timestamp. So this becomes a table or a data set or a data frame that I can work with. Okay. Further, after I have got a cumulative, cumulative data, how did I do? I just used the merge function. So quickly, I would want to also showcase you another very interesting thing. If you go onto the OpenViewer community page, you would see that here you have an option to do some simple coding exercises. And we've also provided the link to those search that I would do. So for this, what you got to do, you simply click this code snippet button, get to the community page. Here, you search for, let's say, a keyword pandas data frame join. You want to join pandas data frame. So that is the search that I'm making here, and hit find. And then simply say, I want to go for code snippets only. So go to this code snippets and then search all these available code snippets and find the one which you think is simple and suitable. Okay. So let's say I find this a simpler one. Copy it, click here, say new notebook. And within this new notebook, I just copy pasted it, Control C and Control V. Now, if I run this, I get an error. There is an invalid syntax, so I will correct it. There is a missing brace. So I will add those brackets here. Rerun this. Now I see that, okay, I have my merged data frame. But even before I see this, I would like to see my individual data frames. So let's say I want to print left data frame and I want to print the right data frame. Print right. And then let's just check these. So the left one, if you see the left one, there are three columns: ID, name, subject ID, and it has 1, 2, 3, 4, 5, and these are the corresponding names as well as the subject ID. Okay, subject 1, subject 2, subject 4, 6, and 5. Similarly, for this right data frame, we have 1, 2, 3, 4 as the ID, and the name of the people as well as the subject ID. Now I want to do a merger of these. So what will I do the merger on? A common column. So ID will become my common column for merger. So now we will do and check the third one, which is this. Okay, we will do a merger on ID, name, your subject. So you will see that for first ID, which is Alex and Billy, Alex has subject 1, Billy has subject 2, and their ID is same. So similarly, this same simple operation that we just did by copy pasting this code here, I have used this simple merger to create this entire simple data set with one line. Okay. And then we come here to this part of the code. What are we doing here in this part of the code? Here, I have picked one title, let's say Toy Story. Okay. And now I want to get the recommended similar movies for Toy Story. So I've created an empty list called recommended movies. And in this, we just say that whatever is the title, if it is equal to this MJ, which is your Toy Story, then sort the values in descending order, okay, by ratings. I want to get the highest, I want to get the highest ratings of this and stored it in the movies underscore database. What I'm trying to do, this movie, which is Toy Story, I want to sort it based on the highest ratings. So I will get the users who have highly rated this movie as the next step. Okay. So for what I will do, I will put up a loop where I will say for user in this extracted data frame, I want to get the top 5 users, okay, top 5 users who have highly rated this. So keeping ascending equal to false means I am getting the descending order of the ratings. How are we sorting it? By ratings in descending order. And then once I have fetched those values for the users who have highly rated this Toy Story, now I want to get the other movies that are rated by this user. Okay, this particular user who has rated other movies, now I want to get those movies. And from that list rated movies by this user, now from this I want to extract again the ones top 5 movies which this user has highly rated. Getting it? And then that I am storing in rated movies. So I am continuously running this loop for 5 times for each user. And then I am adding it to a list. And I am then adding it to a list. And then after I have extended this recommended movies and I added this list of rated movies by each user, I know if one user has highly rated Toy Story, that same user has highly rated, let's say, Dalmatians, American Tail. Other 4 users may have also highly rated these. So the list may have duplicate values for Dalmatians in a particular movie. So then I have used NumPy, alias called np.unique to just get the unique movies, and then that unique movies is what I am storing here. And then I am simply printing that. Okay. And then I am simply printing these movies here. So these are all the movies for the 5 users who have highly rated this Toy Story. So this is one of the method. One user liked Toy Story highly. What all are the other movies? We have given recommendation. What is the other method? The other method is, let's say, similarity of the genre. Let's say this movie called Toy Story. We want to see what are the different genres it belongs to: adventure, animation, children, comedy, fantasy. So there are 5 genres. What are the other movies? What are the other movies which have this same genre? All these. So we have split this first separately and stored it in this. Then we have said for movie in recommended, this is an iterator, and we have said locate the title this Toy Story, and based on that we want to split for the different genres and get to a recommendation initially, and assign a score. Let's say initially this score is empty. We want to get this, for this particular Toy Story, we knew that it belongs to 4-5 genres. what are the genres, what are the movies which we can find have this similar genre, and again we are incrementing those movies which belong to also adventure, children, fantasy, whatever. And the ones we add the score to one every time a certain movie has adventure and another genre, whatever genre got stored in this G movie genres, we added a score. Okay, we incremented the score, and then finally we want to check the score of we want to store the score here, and then we want to say sort on the basis of score in the reverse order. The highest score, whichever movie has the most genres similar to the Toy Story, I want to keep it up. So American Tail has the same genres. Okay, American Tail is having the same genres. Let's just give some other movie. Okay, let's say I give this back Black Butler Book of Atlantic and check the results. Okay, I changed this and then I run all the cells again. Can you see that the number of recommendations based on the users highly rated this Back Butler have got us to this recommendation, and then based on genre, the top movie that I'm getting is Wolf of Wall Street and then Avengers. So you see that the suggestion based on different way in which we are doing recommendations will vary. So I hope this was interesting for you to learn. I would like you to experiment, put down your questions now into the comments so maybe we can take them one by one. And in the meanwhile, I would like to sum up what all we tried to discuss in today's session. So we tried to cover with you the concepts of the essential libraries that we use for data science, like your NumPy and Pandas. We discussed how using the different data sets you can perform operations like merge, sort, and get to a point where you are able to build up a recommendation system of your own in a single click candy kit that you can set up onto your system directly by following the instructions that we listed down. So I see that we have this question from one of our community members where they are asking that based on the different options that I used to create a solution, like the solution for recommendation, how can I handle missing data in a movie recommendation system if I'm using Pandas? Okay, so to be able to handle missing data, there are a number of ways. One common approach is to input whatever are the missing values, or like how can you do that? By calculating the mean or median of the available data for that particular user or movie. Another approach is we can use matrix factorization techniques such as singular value decomposition or alternating least squares. That could be also one of the good techniques to fill in the missing values based on the patterns in the available data. And if the data is related to demographics, right, then you can use external data sources to supplement the missing data. So simply most appropriate is if it is not too much of missing data, we remove the missing data, and if it is too less or unreliable, for effective data analysis. Okay, we also have another query, which is a very interesting question as to how we can evaluate the performance of a movie recommendation system that we have created using Pandas. So there are different metrics that are used to evaluate the performance of a movie recommender system. One metric is mean absolute error, MAE, which measures the average difference between the predicted and the actual ratings for whatever is the test data. Another metric is root mean square error, which measures the square root of the average square distance between predicted and actual rating. So RMSE, mean absolute error, precision recall, These metrics can be used for evaluating the quality of recommender systems. Okay, so I hope this was helpful, and we look forward to you asking more questions on the community platform. Thank you.
Thank you, Pooja, for that lovely session. For all our viewers and bootcamp participants, we hope you enjoyed the session and found the use case that was presented valuable. Please note that all of you who participated will be eligible to receive certificates for this bootcamp. In order to receive your certificate, please complete the assessment by answering two very simple questions. You can do that by scrolling down from on the same page where you're viewing the bootcamp today. You will find a Take Assessment button. Click that button and complete the assessment. You should then receive your certificates in less than a week from today. We will be conducting such bootcamps frequently and regularly. So if you'd like to stay updated with our program calendar, do join our community on community.openweaver.com. This community is where we will connect with you. It helps us receive feedback from you. It helps us understand topics for future bootcamps. But also you can use this community space to collaborate with each other, to ask us any questions and receive clarification if you'd like, or just share your projects and anything else that you would like to in the world of open source. So do join our community and also follow us on our social media channels to stay updated on information and trends in the world of open source. With that, I would like to thank you all for your participation today, and I look forward to seeing you in yet another bootcamp very soon. Thank you and good evening.